Let's see. Hey, oh, clicked on the wrong thing. How are you both doing?
Good. How are you?
We're doing great. So you are talking about Windows APIs and everywhere with .NET.
Yes, that's right. So I'm Mike Batista. I'm a program manager on the Windows Developer Platform team.
And I'm Angela Zhang. I'm also a program manager on the Windows Dev team and excited to be here today.
Yes, and the agenda for this session. So we're going to go over how .NET apps can easily access any Windows API and some of the new work we've been doing to make that even easier. Specifically, we'll be talking about calling WinRT APIs via C# WinRT and calling Win32 APIs via a new project called C# Win32. And as we go, we'll define what those things are. So before we get into that, so what are some examples of Windows APIs that you might want to call in your .NET apps? So there's some on the screen here on the right. You can see that there's modern UI and input, gaze tracking, shell integration, machine learning, the thousands of others. And many APIs are available that enable new interesting scenarios. We've got Windows Runtime apps, Windows Runtime APIs in the SDK, which are the modern style of APIs that we've introduced in recent years. And then we've got Win32 APIs that have been around forever that provide a lot of unique functionality, source compatibility with existing code, down-level support. And we want it to be just as easy to call any of these APIs in your .NET apps. So our general strategy, just to define that and some terminology that's important here, is that we are describing all Windows APIs in metadata. And we're using WinMD files for that, Windows metadata files, which are basically just ECMA 335 compliant metadata files that describe the API surface. Once we have the APIs described in metadata, we use language projections to provide the developer experience. So the metadata describes the API, and then the language projections provide the developer experience for a given language. And once we have projections based on the metadata, we want to make acquisition of those tools as easy and seamless as possible. As .NET developers, you're used to certain workflows and you use the .NET CLI and NuGet. So we don't want you to have to install some massive MSI with a bunch of stuff you don't need. We want to make acquisition of these tools really easy, and we want that to fit into your natural workflow. So C# WinRT, we can define that now. It is the C# projection for WinRT, and C# Win32 is the C# projection for Win32. And now Angela's going to go into some detail on what C# WinRT is and provide a demo.
Thanks, Mike. All right, so I'm going to share on my side. So first, I'm going to go a little bit more into the background of C# WinRT, and then I'll be showing some demos that use WinRT APIs. So C# WinRT is an open source project. We're out on GitHub. We had our V1 release in November that went along with the official .NET 5 release. And as Mike was mentioning before, C# WinRT is a language projection for the Windows runtime. And a language projection is an interop assembly. So what C# WinRT does is we build these projections from Windows metadata files. In particular, we build the Windows SDK projections from the WinMD files that describe the whole WinRT API surface. So with these Windows SDK projections, we've integrated them with the .NET 5 SDK, and they're used to support .NET 5 Target Framework monikers, or TFMs. And with the TFM, you get an easy, streamlined way to access the WinRT APIs. All right, so going a little more into detail with accessing WinRT APIs using the TFM. The TFM is a project property that you would specify in your .NET 5 apps. And to use it, you target a specific Windows version, and by doing that, you get all the APIs available on that specific version. So here on the left-hand side, you can see that the supported TFMs currently are the last 3 versions of Windows, the latest being version 2004 or build 19041. And so when you add the TFM to your project file, what it does is it automatically adds a NuGet dependency into your project, and it pulls in both the Windows SDK projection along with a runtime assembly, which is a helper library for lifetime management. And both of these assemblies are produced by C# WinRT. Also, in .NET Framework and .NET Core 3, you would still need a NuGet package reference to the contracts package if you want to access these APIs. Moving forward to .NET 5, though, you would use the TFM instead. And so now I'm going to go into some demos. I'll be showing 2 demos today, both of them using WinRT APIs in .NET 5 WPF apps. And the first demo, I'll be showing the geolocation APIs, and my second demo, I'll be showing some WinML. And so now I'm switching over to my Visual Studio window. And here I've started up this WPF app. The app itself, here's my window, and I have a Locate Me button. And so when I click on this, it's going to call into the geolocation APIs. And here on the right-hand side, you can see it displays my location coordinates. And so the way I was able to call into these WinRT APIs is by using the TFM. So here, let's look into my project file. I'm going to stop this app. And so this is the project file that I have for this app. You can see it's a WPF app, and I have the target framework specified here. And for this demo, I'm using the latest Windows SDK version. You can also see the 2 other versions that are supported. And then down at the bottom here, you can also see that it's possible to multi-target your apps as well. So in the case where, for example, if you wanted to target both .NET Core 3 and .NET 5, then you can do that. All you need is this package reference conditional statement. So you would need to add in that contracts package if you're targeting .NET Core 3 or .NET Framework or so on. And so now looking into my main code file, you can see with the TFM, what it brought in was under my dependencies. You can see here is the Windows SDK projection along with the runtime assembly, which gave me access to this namespace under the WinRT APIs. And I'm using these geolocation APIs inside my button click handler. And here I'm just creating a geolocator object, finding my position, and then displaying that onto a text box. And so that's the end of my first demo showing geolocation WinRT APIs. I'm going to switch over into a separate instance of Visual Studio. And for this second demo, I'm going to be showing an example of how you could use WinML in your apps. And WinML is pretty cool. It was shipped inside the Windows OS starting with build 1809. And it's an example of one of the newer APIs we have out there that's really powerful. It's super handy as you can do AI and classification tasks on your desktop apps if you don't want to push data to the cloud. And WinML does all the heavy lifting for the developer, so you don't need to worry about hardware as the engine that the APIs are built upon take advantage of the device it's running on to obtain maximum performance. And so here I have my WPF app. I'll show you what it does. I can upload a picture onto the app, and then I have this detect button, which calls into some of those WinML APIs, and it classifies my image. So here you can see this picture was classified as Granny Smith, and it shows the probability as well, 79%. Let me just show another example. So you can see this photo was classified as a llama with probability 97%. So this is just an example of one of the many machine learning models you could use out there in your .NET 5 apps. And so let's look a little bit more into the code itself. just like before, I have the target framework specified in my project file, and that's what's giving me access to all of these WinML API functionalities. And I've also added these two separate files into my project, one of them being the SqueezeNet Onyx model. So that's the machine learning model I'm using. It's a neural network model that does image classification detection. And then the labels.json file here is a file with all the classification categories so that we can actually interpret the results of our model. And with WinML, you need to add a couple classes into a file here. And so here you can see I'm using the windows.ai.machineLearning namespace, which is referring to the WinML APIs. And I have 3 classes in this file. The first one describes the inputs to my model, and these are passed in as an image feature value. Then I have the output to my model, which is a list of all the probabilities corresponding to all these classifications. And then finally, this last class here is used for loading up and binding my model. And so it also includes this handy evaluate async function, which takes in my SqueezeNet input and then runs that through the model to return an output. And then just real quick, going into my main window file. In this file, I had my upload click handler, so that let me upload a picture. And then the detect button, this click handler loads up my model and my JSON file. Next, it opens up my image file, and then it converted that into an input here. And you can see that I'm calling that evaluate async function from before. And finally, we get a result at the end, order those probabilities from most likely to least likely, and then I'm displaying the classification onto the text on my app. And so those are the demos I have for today. These are just a few examples of one of the many APIs available to you in WinRT. There's a lot of cool, powerful, and modern functionality that you can take advantage of. And so now I'm going to bring it back over to Mike, and he's going to talk a little bit more about C# Win32.
Thanks, Angela. Great demo. So yeah, C# WinRT, as Angela just showed you, is our language projection for WinRT, and C# Win32 is our language projection for Win32. And it's implemented a little differently because of the nature of the APIs, but the model is the same. There's metadata under the hood that describes Win32. This is something new that we've announced within the last month or so. And C# Win32 can actually generate p-invoke signatures for you on demand based on the APIs that you ask for. And this is currently up on NuGet.org in beta form. It's the Microsoft.Windows.CS Win32 NuGet package. And now I'm going to show you a couple of demos of how that works. So I'm going to start with a simple demo. I'm just going to call a simple Win32 API that everybody's familiar with, create file. So this is just a basic WPF app. I've added a reference to C# Win32 here. This is our new NuGet package. And what this enables you to do now is you can, in this native methods.txt file, you can list the functions that you want to call. So in this case, I've listed create file. So now if I go over to my C# code, you can see I've added a using statement for the Microsoft Windows SDK namespace. And now I have this p-invoke class that the C# Win32 package generated for me. And inside here, you can see that I asked for create file, and now I have create file. And if I fill this line out, you can see that I'm getting IntelliSense. There are some strongly typed enums here for things that are traditionally flags. So it's just an example of us projecting the metadata into an idiomatic pattern that you'd expect in C# and whatever the languages that you're using. And as I fill this out, you can see that documentation is also getting pulled in from docs.microsoft.com. This is part of the value of the projection model, is that the projection can provide a great developer experience based on what's described in the metadata. And in this case, it's actually pulling in docs from Microsoft.com and showing them to you in IntelliSense. So as I fill out this method call here, I'm just going to create a local text file. You can see that as I fill out different parameters, I'm getting the specific documentation for the parameter. I'm getting IntelliSense for the enums that map to those parameters. So instead of having to hunt around in the documentation or try to manually redefine these things or figure out what the int values are that I need to pass in, I'm just getting strongly typed enums that are defined in the metadata that the projection is then projecting as enums. So I can select generic read and so on and so forth. You can see that the IntelliSense is continually updating. We're getting strong typing and a very natural experience. So I've already written a full create file call here, which is underneath this hidden region. So you can see I got the pinvoke static class that's coming from CS132. I'm calling create file. Basically, I'm just creating a test.txt file in my working directory, passing in some flags to always create it. And you can see that it's returning a safe handle. So this is another example of the projection taking what's defined in the metadata and projecting it in a way that's idiomatic to C#. And safe handles is the C# way to deal with native handles, and the projection is providing that experience for you. So I've already got this app built just to save some time. So here's my working directory. Here's the WPF app. So if I run this app quickly, you can see that it dropped a text file here. The timestamp is 3:16, so it matches the local time. So I just successfully called into the Win32 create file function just by adding CS132, asking for create file, and then having all the, leveraging all the pinvoke signatures that were generated for me. Now, if you're writing a lot of Win32 calls, prefixing all of them with pinvoke could become a little tedious. So it'd be nice if you could just do this. And you can see that it's actually compiling. It's not providing any warnings or anything. And that's because we're using, again, another nice feature of the language, which is the using static statement. And we're actually, because pinvoke is a static class, if you write using static pinvoke here, you can basically effectively promote all of its members, all of its static methods to the global namespace. So now this function call looks a lot more like if you were writing Win32 code, you can just call create file and it just works. So it's up to you. We like to enable choice. So if you're okay, if you're using a few APIs, you're okay. There's not too much noise to add these to the top level namespace. You can just add using static pinvoke and then get a more Win32-like experience just calling functions. And that's what this region here demonstrates, is the difference. You can call them directly on pinvoke, or you can just use using static and then call them directly. So this is an example of calling one specific function, but we also support things like wildcards. So if you're, let's say you want to call bcrypt APIs and you want to use all the APIs in the bcrypt module, we actually support things like this, where you can say bcrypt.star. Bcrypt is the module that these functions are in, and C# Win32 will generate all the bcrypt APIs in that module. So if I open up this region here, and because we're using static, it's in the global namespace. So now you can see I'm actually getting all the bcrypt APIs generated for me. I didn't have to go write pinvoke signatures or do anything crazy. Everything's generated based on the metadata, and C# Win32 is taking care of that for me. And again, these are generated on the pinvoke class. If you want to just call them there, that's where they're coming from. The using static statement will promote them to the global namespace, and you can call them like you would in a real Win32 app. So that's a simple example. I mean, create file, obviously there are file system APIs in .NET you can call. This is just a simple example just to show you the mechanics of what the projection can do. So now I'm going to switch over to a little more complicated sample and also a different flavor of API. So this was a Win32 API, but this actually also supports COM. We support COM APIs in this projection. So I'm going to switch over to, I'll run the app first to show you what this is. So this is a COM spell checker API. And basically the interface is you pass in some text that you want to check, and you submit it to the spell checker engine, and it comes back with some suggestions. And you can see here that the first word is misspelled, so I'm getting suggestions for alternatives. I have I duplicated here, so I'm getting a recommendation to delete one of those instances of I. And then there's a typo in this word, and I'm getting a suggestion from the API to replace the typo with a correct spelling. So here's the COM code, and using what we learned from the prior example, so I have a reference to the C# Win32 NuGet package. I've got native methods.txt, which has the COM APIs that I'm asking for, and additionally some constants that I want to use in my code. And in my code now, I'm basically, again, I'm using static so that my C# code here looks more like the original COM code. And if I scroll through here, you can see, if you've never done COM programming before, this could be a little overwhelming or complicated or unnatural for C#. But to be able to pour original COM code into C#, we're doing a lot of translations here to make it a little more idiomatic, so that you can benefit from existing code. If you come across some COM code or COM API that you want to use in your app, it's really easy to translate it into C#. And just to scroll through this quickly, you can see that we're just calling co-create instance on the spell checker API, checking if the English spell checker is supported. If it is, then we create the spell checker. Here's the text that we want to check, and we submit it to the checker engine, and then we basically loop through. This is just following the COM API interface. Loop through the errors, extract the word that has the problem, and then switching on the corrective action. So this is where, in the console app, you're getting different suggestions based on the word that was incorrect. And you can see here that we're switching, we're using enums. And depending on the corrective action, I console write line, delete this word, replace it with something else, or I enumerate through suggestions and then add them to a list and then write those to the console. So I'll dive a little more into this code just to describe a little bit more about some of the niceties that the projection is providing here. But just now that we've seen the code, I just want to run it one more time. So you can see that we used COM to instantiate the spell checker API. We made sure that the English spell checker was available. We passed this text in, and then we just used it's the C# language. We didn't have to write any native C code. We used switch statements. We used spans and other things that are inherent to C# that you'd be familiar with as a C# developer. And I just called the spell checker COM API in a .NET console app. So some of the nice things that that the projection is providing is you can see that, again, we're promoting these things to the global namespace using static. We've got things like out parameters, so we're passing them in and defining them in line. So you don't have to go jump through any hoops to do void stars and converting things with pointers. And we're getting types remapped. Here, type inference. I'm using C# to do simple string manipulation, generic lists. So the COM code we're using, we didn't have to do any COM imports, or all that stuff was generated. And then we're mixing that in with the C# language. And just to show you for comparison, just to show you the original COM code. So we've got that. I actually took this from an old MSDN magazine article from one of my teammates, Kenny Kerr, and translated it from COM to C# with very little COM experience, and it was very natural. So you can see on the right, so here's the original COM code, and it's a very straightforward translation. You can see some things like UUID of map to these types of patterns in C#, and our samples like this will demonstrate that, so you shouldn't have to figure that out. It should be demonstrated in our samples. And as I scroll down, you can see that it's pretty much a straightforward translation. So if you have existing COM code that you want to use in your app, C# Win32 makes it really easy. And we just announced this project a few weeks ago, so it's pretty new. The packages are in beta, so we have a lot of ideas for how to make this code even more idiomatic. Trying to minimize the need to use pointers, turning things like this into property getters. So we have a lot of developer experience improvements we can make, and we will be making over time. But this just is an early example to show you what's possible with this model of having APIs defined in metadata, and then having projections like C# Win32 provide the developer experience. So those are my demos. So just before we head over to Q&A, I just had a couple more slides to close out. So we have an upcoming event. So next week, the author of C# Win32, Andrew Arnott, is going to be doing a live cast on his Twitch stream, on his Twitch channel. And if you've used the .NET P-Invoke project before, you might recognize the name. So Andrew is the author of that project, and we partnered with him to prove out this model and build this C# Win32 projection. So he's going to go into a lot more detail on, a lot more detailed demos, roadmap discussions. How does this relate to .NET P-Invoke, and what's the future there? And we'll take live Q&A. So definitely, if you're interested in this area, we're happy to have you there. And Andrew's really excited to have a chance to talk with everybody and demo his work next week. So looking forward to see everybody there. And all of this stuff is being developed open source. So these are our GitHub repos. We've got the C# WinRT projection that Angela demoed, C# Win32 that I just demoed, and then the Win32 metadata repo is where we're doing the work and building the tooling to actually scan the SDK and generate the metadata, the WinMDs that these projections are building on. We're not handwriting IL or doing anything crazy like that. We're actually scanning the SDK and then emitting WinMDs that these projections can build on. And again, we're focused on C# here, but one of the benefits of this model is that it scales out to additional languages. So any fixes we make in the metadata actually benefit all the projections that build on top of it, which is really valuable. Yeah, so that's our session. So now we're going to open it up to questions.
Sorry, I was muted. We don't have any questions, but the pinvoke stuff is crazy. That is amazing work that I can actually do all that for you. As you were presenting, I went to my bookshelf and I grabbed this bad boy. This is back when I was doing a lot of Windows development, and by Adam Nathan. It's super thick, as you can see on it. I can use it as a door stopper or to pretty much hold on to a house. But yeah, there's a lot of stuff that you can do with pinvoke and pinvoke.net and everything. It's great that you can do the native methods tags, and it will generate all that for you. Because the biggest thing was whenever somebody submitted something in pinvoke.net, it would be off. It'd be like, oh, it should be a 3 rather than a 2 or anything else.
Yeah, it's very easy to get wrong. pinvoke.net's pretty old. So Andrew's project, the .NET pinvoke project, is kind of the state of the art there. But even then, API coverage, Andrew will be the first to admit API coverage is spotty. It's high maintenance for him to manage that project on the side.
Right.
So being able to just encode the patterns in the projection and then have that applied to the whole API surface it's going to improve the API coverage of projects like that. It's going to make his life a lot easier in terms of just maintaining them.
Right. So
it will benefit other languages as well.
So can you, and maybe this is on the roadmap, and this is just from taking old patterns from pinvoke, can you take the native methods tags and saying, hey, I don't need you to create them every single time, because it's a signature. Once it's done, it's there. Can I take that and export that as its own assembly, or would I just create a separate project that has the native methods tags, generate everything for me, and then I just reference that assembly where I need it?
Yeah, I think so. I think we're going to pre-build some of these assemblies. So I think
perfect.
Andrew will go into more details in his livecast next week. But yeah, you could imagine, if you don't want to generate these things all the time, we could pre-build libraries just like, today .NET pinvoke is a set of NuGet packages. And also, again, so source generators is a C# specific thing. There are no questions on Twitter right now, but some people may ask about that. So having pre-built libraries will allow you to use this type of coverage, get this type of API coverage in other languages like F# and VB. So we do have plans. Again, Andrew will go into more details next week on his stream. So I encourage everybody to attend. But we do have plans to make this available to more languages, have that pre-built model if you're more comfortable with that. But also, we don't want Andrew to have to maintain these things twice. So use the source generator as the primary source, pre-build the libraries, publish them as pinvoke style packages. And then if you want, enable you to mix and match. If you want to use the libraries, the pre-built libraries for many things, and then also mix in some source generation, that'll be possible as well.
Yeah, in particular, like you were showing the COM aspect of it. I wrote most of the COM that I wrote was with MFC and just the ATL, but it just got verbose. And the ability that you can take something like that, copy it, literally just copy paste it. It was like just minor changes here, obviously because of different types, and be able to reuse it on a C# application was amazing. Yeah,
and like I said, we're hoping to make it even more. It was very true to the original in this demo, and we definitely always want to support that for performance reasons and just for code portability reasons. But we also want to provide the options to get that more idiomatic C#. So we're really all about choice here. What language do you want to use? What APIs do you want to call? Do you want the more idiomatic flavor? Do you want the raw underlying performance? We definitely don't want to box you into one. We want to open it up and give you the options to develop how you want.
So the one question I was wondering, so when you had that COM, did it actually create the unsafe block for you as well? Or was it something that you had to always remember to wrap it, because there are people who forget to do that?
Well, as soon as you start using pointers, if you try to compile, it'll tell you need to put pointer code into unsafe. And that's really what unsafe means. Is just, okay, you're starting to use pointers now that it's not memory managed for you, so make sure you do the right thing. And one of the things that, like moving to just making the COM projections real interfaces, as part of that transition, as we get more work done here, we'll very, very likely be able to remove the need to use unsafe in most places. But in cases for, depending on the API, there may be cases with COM where you need to use the pointer interface just based on the nature of the API. Maybe you need to check an H result or something. So there definitely will be a need, and we'll support the ability to just write unsafe and write that raw COM equivalent code. But for the majority, we'd like to get to a place where you don't need to wrap it in unsafe, and you can just treat the COM projections as just C# interfaces.
Yeah, that would be awesome. So I was going to say thank you so much, Angela and Mike, for taking the time to present. So we're thankful that you take the time to share your knowledge and awesomeness of the project. Sounds like they're early on. Can people contribute to it?
Yeah, absolutely. I think go ahead, Angela. Sorry.
Yeah, everything's open source. So in our last slide, Mike had those links to the repos for C# WinRT and then C# Win32. And so feel free to check out our repo. You can ask questions or submit an issue or any feedback that you have for us.
Perfect, great. I'm going to say, yeah, everybody always out there, put a PR in there so we can, the project can get better. So
yeah, and so the C# WinRT stuff is a little more mature.